Alright, this is gonna be fun. Alright, so we're dealing with our integration by parts still. Alright, now obviously if you had something like an x squared in front, the previous examples were all linear, and so the x went away pretty quickly, or the natural log that turned into 1 over x and the natural log was gone. This one obviously, you know, if you make x squared u, then when you do the derivative it's going to be 2x, and so you're going to have to go through the integration by parts twice, right? So I'm not going to work through that one because that one I'm pretty sure that you can figure out on your own and kind of work through. In fact, if you want to, you can go ahead. Here's the answer right here. Boop. But of course that's not the one I want to look at right now. So we're going to leave that one off on the side. And yes, you can do that one if you want. And here we go with e to the x sine of x. Now, looking at this one, you'll recognize that nothing's going to go away very easily. In fact, it's going to keep happening, right? E to the x is going to keep being e to the x, sine of the x and go to cosine, and this can go back to sine, right? So you may say, well, integration by parts is going to be stupid here because you're just going to keep going forever, Mr. Bywater. Well, no, I'm not. Watch this. This is going to be, I'm telling you, this is going to be cool. So, we're going to make e to the x u. And we're going to make sine of x our v prime. Okay? So, with this, that means we're going to say u equals e to the x. U prime, of course, is e to the x. V and v prime. V prime is, of course, sine of x. And then the integral of that would be cosine of x. Okay, so there we go. Sorry, derivative of cosine x is negative, so negative cosine of x. So we'll go ahead and we'll put this in. So we'll go u, which is e to the x, times v, which is negative cosine of x, minus the integral of, why do you keep doing that? I don't understand. E to the x, go away. Okay, here we go. Times v prime, times v, which is negative cosine of x. So cosine of x, I'm going to put the negative in front just because I don't like negatives, dx. Alright, so obviously you say, that got you nowhere. Okay, well, watch this. We're going to do it again. Okay, so step 2, again, we're going to make e to the xu. We're going to make cosine of x v prime. So I've got u equals e to the x. U prime, of course, is still e to the x. V and v prime. V prime is cosine of x. So v is sine of x, right? The derivative of sine is cosine. So that should make sense. And we'll go ahead and put it in. So now I've got that the integral of e to the x sine of x, because that's what it was. Okay, sorry, I should have a dx on there. And that should be equal to negative e to the x cosine of x. Okay, then I've got plus, so I'm going to put u times v, so plus e to the x sine of x. And then I've got the minus integral of u prime, which is e to the x, times v, which is sine of x. Okay, now, I know what you're thinking. You're thinking, but Mr. Bywater, you got e to x sine of x on this side. That's what I started with. You're going to keep going forever, man. Watch this. I'm going to add the integral of e to the x sine of x, the x to both sides. What? You can do that? No. You've been doing it since Algebra 1, right? So now, what do I get if I add two things that are the same together? Well, I get two of them. So I got 2 integral of e to the x sine of x. I told you this is going to be cool. Is equal to negative e to the x cosine of x plus e to the x sine of x. Now, how do I solve? Well, I just simply divide by 2. And that leads me to my final answer. Because when I divide this by 2, I get the integral of e to the x sine of x dx is equal to negative e to the x cosine of x plus e to the x sine of x all over 2. Done! Just kidding, we need a plus c. Once you put the plus c down, now you're done. What do you think about that one? Cheers!